Today's video is on Prim's algorithm. So this algorithm helps in finding the minimum spanning trees, and this topic is from graph theory. So the algorithm states that the first point here is select an arbitrary start vertex. Next, at each stage, choose the edge of smallest weight joining a vertex already included to the vertex not yet included. Continue until all the vertices are included. So these three steps I am going to follow. So here is an example. So this is a graph given. So in this graph, if you observe how many vertices are there? A, B, C, D, E, F, G. Total how many? 1, 2, 3, 4, 5, 6, 7. Total we have 7 vertices. In order to create a spanning tree, so we have to maintain the same vertices. Here the vertices are 7. So in the spanning tree, so we have to maintain edges n minus 1. So if n is equal to 7, we have to maintain n minus 7. That is 7 minus 1. That is the 6 edges we have to maintain for spanning tree. See here. So all the edges are maintained here. That is A, B, C, D, E, F and G. So this is going to be the answer, and this I have drawn for explaining you. See, in the whole graph, choose an arbitrary vertex. So in this, I am choosing the edge AB. See here, this is AB. So this is A and this is B. So in this, the weight here is 2. So the same thing I'm writing here, I'm choosing 2. And the next one here for A, how many edges are there? This is 3, 3, 2. How many weighted edges are there? This is 3 and this one is 3. See, there are 3 edges. For B, there are 3 edges. That is 2. This is 4 and this is 3. This one is 3. So I have used 2 here. So I'm cancelling this 2. And among all these 4, so which one is the minimum? So 3 is the minimum. So you can select any one of these 3s. So I am selecting this one as 3. So this one is 3. I am cancelling this and it is connected to E. So this one is E. So E has how many edges, weighted edges? So this one is 1. This one is 8. So among all these, so which is the minimum one? 3, 3, 4, 1 and 8. Among all these, so 1 is the minimum. So just I'm writing this weighted edge, the minimum weighted edge as 1. So it is connected to C. So therefore C. So C has how many edges? 1, 2, 3, 4, 5. So this one, it is connected to 5. So all the edges I am writing here 6. So these are all the edges of C. And now 1 is posted here. And out of all these, which one is the minimum? 3 is the minimum. So among these two, I am selecting this one, this edge 3. So it is connected to D. Write all the edges of D, 3, 5 and 7. So this is 7. So this 3 I have posted. And now among all these, so this is 3, 5, 7, 4. Which is the minimum one? 3 is the minimum. So if I join like this, a cycle will be formed. Therefore, I am cancelling this 3. And next minimum weighted edge is 4. So if I join like this 4, a cycle will be formed. Therefore, I am cancelling this 4. And next minimum weight among these is 5. So if I join like this, a cycle will be formed. Therefore, I am cancelling this 5. And next minimum weighted edge here is 6. So if I join like this, 6 cycles won't be formed. So it is connected to F. See here. F has how many edges from the main graph? Towards D, towards C, towards E and towards G. So this is also included towards G. And this 6 is cancelled. And next among these 3, which is the minimum weight? 7 is the minimum weight. So if I draw this edge 7, cycles, a cycle will be formed here. So this will be a cycle, and therefore 7 it's excluded. And among 8 and 9, so if I take 8 here, a cycle will be formed here, therefore I'm cancelling this one. And next, what is left here? 9. So for 9 there is no problem of forming cycles, and therefore 9 is posted here. So if you observe this one, so this is the minimum spanning tree, and therefore the minimum weight here is, see, the minimum weight here is, if I add up all this is 3 plus 2 plus 3 plus 1 plus 6 plus 9. See here, this is 10, 15 and 6. This one is 24. So the value here is 24. Got it? So this is the solution. So this is the solution, that is we got the minimum spanning tree. If you observe this one, so we have n vertices, 7 vertices, and we need 6 edges. See, count 1 2 3 4 5 6. What is the speciality of this minimum spanning tree? The spanning tree is nothing but, so we have to maintain all the 7 vertices. 7 vertices are maintained, that is 1 2 3 4 5 6 7. And edges here are n minus 1 6, that is 1 2 3 4 5 6, 6 edges. Are there any cycles or loops or circuits? No. Then this is the spanning tree. So among this, so the minimum weighted edges we have connected, and the minimum weight for this spanning tree is 24. This is according to the Prim's algorithm. So I'll give you some more examples, the most important questions. So I have explained you clearly, and now this time we are going to solve this one. So this is the graph given. So among this we have to choose one arbitrarily. So now I am choosing the minimum edge here, 1. So the minimum I am connecting this as 1. So that is dB 1. See here, here also this is D and this is B. So all the edges you have to connect, that is 2, this is 4, this is 1. And see, for B, how many edges are there? This is 3, this is 7, this is 4, this one is 8 and this one is 2. I have chosen this one, 1. And among all these, what is the minimum one? 2 is the minimum one. So I am selecting 2. So 2, this is connected to E. Therefore, I am inserting E, and E has 3 edges, 3, 7 and 10. Now I am cancelling this one. This is already posted. And see, among all these numbers, so which one is the minimum? 2 is the minimum. So I am connecting this 2. Weighted edge 2, and this 2 is connected to A here. So how many edges are there? This is 4, 2 and 3. So now I have to include this one. So 2 is posted. I am cancelling. So among all these, what is the minimum edge here? This is 3. If I connect like this 3, a cycle will be formed. Therefore, it is excluded. And next, see here, I can take this one, 3. So this 3 is selected. So this 3 is selected. 2 2s are completed. So this is the 3 we have to take. And this is connected to F. This is connected to F. And see here, F has 1 as edge. So I'm cancelling this one. And the next one, 1. So this is connected to G, and it has 1, 4 and 6 from the main graph. So what is the next minimum number we have? So we have 1 as a minimum number. So this is 1 and it is connected to G. G has 4. So among all these, this is these 4, 8, 7, 10, 6. So if I take this 4 as a minimum edge, cycle will be formed. Cancel. So if I take this 4 and connect, cycle will be formed. Cancel this one. So among this is 7, 8, 6, 10. So which one I can take? 6 I can choose. So I'm taking 6. I'm cancelling this one. Next, the minimum thing here is 7. So if I connect like this, cycle will be formed. Cancel. And next one, if I take this 8 edge. So cycle will be formed, cancel. Again 10 also, cycle will be formed, cancel. So here the minimum weight here is 2 plus 2 plus, so this is 1 plus 1 plus 3 plus 6. So this is nothing but 4, 5, 6, 12, 13, 14, 15. So the 15 is the answer. So if you observe this one, how many vertices are there? 1, 2, 3, 4, 5, 6 and 7. So vertices are 7. So for the spanning tree, we need n minus 1 edges. So n minus 1 means 6 edges we have to maintain. See, 1, 2, 3, 4, 5, 6. So 6 edges I have maintained, and there are no cycles, no loops. And this is the spanning tree. And out of these spanning trees, so 15 weight is the minimum spanning tree. Hope you got it. And next thing here is, so this is then another question. Let's get started to solve this. So how many vertices are there? A, B, C, D, E, F and G. Total 1, 2, 3, 4, 5, 6, 7. So the vertices here are 7. Here we have 7 vertices and we have to maintain n minus 1, 6 edges. So among all these, I am choosing this AB. So A to B. So this is A to B edge I am choosing. After choosing this one, A. So this is A and this is B. So this is 10 I have chosen. So for A, how many edges are there? 2 edges are there. So one is 28 and 10. And for B, how many edges are there? One is 10 and another one is 25. So I have posted this 10. And see, among these two, which one is minimum? 25 is minimum. So I am connecting with this edge. So I am connecting to E. So I am posting E, and E has 3 edges, 25, 24, 22. So this is 22 and this is 24. So I have posted this one, cancel this one. So among 22, 24, 28, which one is minimum? This one is minimum, 22 is minimum. So I am connecting to G here. So this one is G. So G has how many edges here? 3 edges, 22. This one is 18 and this one is 12. So 22 I've posted, cancel. And next, among 12, 18, 24, 28, which one is minimum? 12 is minimum. So I'm posting this 12 and I'm cancelling. So it is connected to F here. So this is F. And see, F has how many edges? 12 and 1, 16. Got it? And now among 16, 18, 24, 28, which one is minimum? 16 is minimum. So I'm connecting with 16 to C. Now C is connected. So C has 3 edges. So join this one and this is 14. And C, 16 is posted, and among 14, 24, 18, 28, which one is minimum? This 14 is minimum. So I'm connecting with 14 to D. So D has how many edges? 1, 2, 3 already posted. And see, 14 I've posted and I'm cancelling this one. So among these three, which one is minimum? 18. So if I connect this one, a cycle will be formed. Therefore, I'm excluding this one edge. And next thing here is, so if I connect 18, a cycle will be formed. And next minimum one is 24. So if I connect 24 like this, again a cycle will be formed. And for 28, if I connect like this, cycle will be formed. Therefore, this is also cancelled. So vertices here are 7. 1, 2, 3, 4, 5, 6 and 7. Edges here are 6. This is 1, 2, 3, 4, 5, 6. And this will be the final answer. So if I start from here, the minimum weight, this is 10 plus 25 plus 22 plus 12 plus 16 plus 14. So if I add all these, so this value will be around 99. So this is 99. So this value is 99. This is how we have to solve, and this is another question for you, and this is the main graph given. So among this graph, how many vertices are there? See, I'm showing you the vertices A, B, C, D, E, F. 1, 2, 3, 4, 5, 6. So total they are 6 vertices. So how many edges we have to maintain? N minus 1. 5 we have to maintain. So here the same vertices I have posted, and see, I have to select arbitrarily any edge here. So I am selecting this A to B. So A to B edge is 2. See here, this is A and this is B. So for explanation, I have drawn this one. This is 2. For A, how many edges are there? 1 is 2 and 1 is 3. For B, this is 2 and 3. So out of all these, 2 is posted. See, got it? And the next thing here is 3. 3 is the minimum value. So I have to select 3. So I am selecting C. This is 3. It is connected to C. So C has how many edges? 1, 2, 3. So this is 4 and this one is 5. 3 edges we have and 3 is posted. So among these 3, which one is minimum? 3 value is minimum. So I have to connect this edge. So this is 3 and this is connected to D here. So D has how many edges? 1, 2 and 3. So this is 3, 2 and this one is 3. So I have posted this 3. And next one, among these 4, which one is minimum? 2 is minimum. So this edge 2 am joining to E. So this one is E. See, E has 3 edges. So one is 4, 2 and 5 and 2 is posted. And see, among these 3, so which one is the minimum value? So 3 is the minimum. So I am connecting 3 to F. So F has 3 edges. Got it? And next one, 3 is posted, cancel it. And next minimum thing is 4 here. So if I connect 4 like this, a cycle will be formed. Therefore, cancel this one. So if I select 5 here, cycle will be formed. Cancel. If I select 5, again cycle will be formed. Cancel. And therefore, this will be the minimum spanning tree. See here, how many vertices are there? 6. 1, 2, 3, 4, 5, 6. Edges here are 5. 1, 2, 3, 4, 5. There are no cycles, no loops. And here if I add this one, so this will be 2, 3 and again 3, 2 and 3. So this is nothing but 6, 6, 12 and this value is nothing but 13. So this is 5, 5, 10 plus 3, 13. 13 is the minimum weighted graph, the spanning tree. And the next one, last one. See if you understand this one. So this concept, Prim's algorithm is very, very easy. So we have 1, 2, 3, 4, 5. How many vertices are there? So the vertices are very clear as 5. So edges we have to maintain as n minus 1. So this will be 5 minus 1, which is equal to 4. And see, I can select any one of the edge here. So here, if you observe, I'm taking A to B. So this is A to B. This is, sorry, this is 1. So this one is 1. So this is A and this is B. So this one is 1. So for A, I have 2 edges. So this is 1 and 2. For B, I have 1, 2, 3. So this is 1, 7. I posted this one 1. So among these 3, which one is minimum? 1 is minimum. So I am connecting 1 with D. So this one is D. So D has 3 edges. So this is the edge of 5, weighted edge 5 and this is 3. And I've posted this one here. So among 2, 7, 5, 3, which one is minimum? 2 is minimum. So I have to connect this edge 2 to C. So C has, see here from the main graph, it has 4 edges. So this one is 4. Clear? And I posted this one too. So among these 4, which one is minimum? 3 is minimum. So 3 I am drawing here and I am connecting to E. So E has 3 edges. So I am connecting this one to 6. So after posting, I have to cancel this one. So among 4, 5, 6, 7, 4 is the minimum one. So if I connect like this, cycle will be formed. Therefore, cancel this one. So if I select 5, so here if I connect 5 like this, a cycle will be formed here. Therefore, cancel this one. 6. If I connect 6 like this, a cycle will be formed here. Cancel. 7. So if I connect like this, cycle will be formed. Therefore, cancel. So all are cancelled. And now this will be the minimum spanning tree, weighted spanning tree. This is 1 plus 1 plus 2 plus 3. And this value is 7. So if you observe, there are 5 vertices. 1, 2, 3, 4, 5. Edges are 4. 1, 2, 3, 4. There are no cycles, no loops or circuits. And this is the spanning tree, and the minimum weight here for this spanning tree is 7. So this is how we have to do. Thank you so much. I've posted so many examples from previous question papers. And if you follow this trick, definitely you can solve any graph by your own. And if you really like, please do subscribe to this channel and share it with your friends. Keep watching. Thank you.